Okay, so what I want you to do to get started, just read the question, underline your important parts, your VIPs, and kind of get the gist. And then this is gonna get set up a little differently than what you did yesterday. It's a little bit more difficult, but I think after you see how it's modeled, I think you're gonna be okay with it. And plus, you can draw on your knowledge of what you did on ratios to also create a model as well. So read through it, and then we'll talk about it. Okay, so the key ideas here is we're definitely going to need to use this 9 somewhere. And our fraction 3/4. Now here's where this is different from what you did yesterday. We don't know what the whole amount is of the bread used. We just know that 3/4 requires 9 cups. What we're trying to figure out is what was the entire amount of cups to start with. It's kind of like, if you remember when we did part to whole ratios back in unit or module 1, and you'll see we can actually find the answer using a part to whole ratio as well. But the module wants us to model this using fractions. In this example, I'm just going to read from here. In this example, we're not trying to figure out how many. We are not trying to figure out how many 3/4 are in 9. We know that 9 cups is a part of the total amount of the flour needed. So what we're really trying to determine is 3/4 of what unknown number is equal to 9. Now the way they want us to model this is we're going to make our fraction bar like we've been doing. This is showing 3/4, and we've shaded 3 out of 4. Okay, this 3 out of 4 is representing 9 cups. Now, if you remember back when we did tape diagrams back in module 1, if I know that these 3 bars out of 4 represents 9, then how much is each bar worth? Think about it. This 9 is making up these 3 bars, so that each bar has to be worth how much? What do you say?
3.
How many see 3? All right, you got it. 3, 6, and 9. Once you have the value of that one piece, then even this piece here, which we haven't determined, has to be the same. Because when you divide up a fraction bar, all the pieces are equal. Hard part's done. Let's just go and fill in the blanks. We've already done step 1. We started with a fraction bar that showed 3/4. And where do you see this in the problem? It's the fraction. So just fill this in so you have it for your records. Step 2 we've kind of already done. Since we know that 3/4 represents the cups of flour used, which is 9, we're going to shade 3 out of 4 of the sections and label them as representing 9 cups of flour. Well, the first example has done that for you. Then I've already asked you to determine what each section is worth, and that's worth 3. And then if each section represents 3 cups of flour, then the total amount of all the sections is now what? Add it all together. What do you get? Log, you get 12. And that's our answer. 12 cups of flour. That's one way to do it. I'll let you get caught up, and then I'm going to show you 2 other ways to do it. You're going to pick the way that works best for you eventually. But I'm going to show you all 3. Okay, we can also do it using straight division. 9 divided by 3/4. Now, even though I haven't taught it to you yet, I'm going to show you something called keep, change, flip. Keep, change, flip comes into play formally in lesson 7. But whenever you have a division problem, you keep the first number exactly as is, which in this case is 9. We change division to multiplication. And guess what I'm going to do to 3/4? Lauren? Sort of. Keep, change, flip. What do you think I'm going to do to the what am I going to do to that last fraction? Kels. I'm going to flip it upside down, so 3/4 becomes 4/3. Now I also have to ask you this question. The whole number 9 is what as a fraction? You may have learned that in 5th grade also, and again, you're going to see this come into play in lesson 7. Reggie? 3/3 would be 1. It's going to be 9 over something. Kate, do you know? It becomes 9 over 1. Once I set it up as 9 over 1 times 4 over 3, I can multiply numerator by numerator. What's 9 times 4? 36. What's 1 times 3? Diggs. 3. We now have an improper fraction, which is 36 over 3, but I got to change it back into a whole number. So it's a top-heavy number. We call it an improper fraction. 3 can go into 36. How many times? Or the other way to look at it is 36 divided by 3. Jordan. It happens to equal 12. And look at that. We wind up getting the same number. Now, if this confuses you right now, then don't use that method right now. We will revisit it a little bit later on in the module. I kind of compare this to present, future, and this is what we did in the past. Part to whole ratio. You make your template, part over whole. Everybody do that. The given ratio that you get, that they give to you in the word problem, is 3 out of 4. That's our part, 3 out of 4 the whole. Equals, and then I got to ask you the most important question. That number 9, back in the original problem, number 9, that 9 cups, did that represent the whole or the part? And if you need to reread the question again, do that, because this is a very important key question. What do you say, Chris? And he would be right, because we're trying to find the original amount. And now you have an equivalent fraction. 3 times what makes 9? Remember this back from module 1?
3.
Times 3. Do the same to the bottom. And look at that. You get 12 as well. Okay. Let's try one more together, and then I'm going to set you loose, okay? Go to the next one. Read it quietly to yourself, and then I'll come back and talk to you about what the gist is. Okay, ready? 12 is an important VIP, and so is 3/8. What's the question really asking? Log.
How many people can George feed in 12 pieces?
Yeah, how many people can... Say it again.
How many people can George feed in 12 pieces?
Right, how many people can he feed with 12 pizzas, assuming that each person is only going to eat 3/8. There's two ways that we can restate this. It could be 3/8 of what number? Is 12. That's one way of writing it. And then I'm going to show you the easier way. Okay, but write that down for right now, and then I'm going to show you the easier way. This what number is what we're trying to find, or this is what we're going to model. But get caught up, and then I'm just going to show you an easier way to write it. Okay, ready? Or 12 divided by 3/8. In essence, that's what it winds up being. Okay, so now we're going to model it. I have my 12 boxes here, right? How many am I going to shade? Somebody I haven't heard from. Miguel. Right, because it's 3/8. Shade 3, everybody. And I want you to put a little bracket above the 3 that you shaded. Now, those 3 out of 8 represents 12. So now you have to think. Each section, if 3 of them have to add up to 12, what does each section have to be worth? Pete. 4 would work. That's going to make this 4 plus 4 plus 4. That adds up to 12. And we'll put a 4 there as well. Now what do I have to do to figure out how many pizzas he should actually order? Or how, I should say how many people he can feed, because that's what we're trying to figure out. Go ahead, Mike.
We have to fill 4 into all the boxes.
All right, attaboy, good. And then you just got to add them all up. What do you got? Okay, you get 32. Okay? So now, just to go back and revisit this again, what's that 32 represents? He can bring 32 people to his birthday party, and if each of those 32 people, think about a classroom, it's about 32. If each one of you eats 3 out of 8 slices, 3/8, I would have to order around 12 pizzas to feed everybody. That's in essence what we just did, okay? So he can feed 32 guests. Here it is as a division question, and I'm going to kind of do it kind of quick because we're pressed on time. I know we have the shortened periods. 12 divided by 3/8. Everybody repeat after me. Keep. We're going to keep 12 as is. Change. Change division to multiplication. Everybody say flip. Make 3/8 8/3. Twelve becomes 12 over 1. If that's still confusing for you, don't worry. We come back and talk about it a little bit later in the module. Now we're going to multiply our numerators together and our denominators together. What do you get when you do 12 times 8? Anybody do that in your head? I had to do it this morning when I was trying to figure out the scoring for your quiz on Friday. I have 8 questions and each one's worth 12 points. Laura? How much?
46.
Not 46. 6 is right, but the 4 is not. You're on fire, Mikey. Go. 96, Mikey. Mikey's on fire. 1 times 3, just say it out loud. 3. 96 divided by 3, or 3 into 96, is 32. It works out. As a ratio, part to whole. Make the template, P over W. Take the original fraction. 3 is the part out of 8. Equals. That 12 is a part. Trying to figure out the amount of people, which is the whole. Laura.
You're going to times by 4 and you're going to get 32.
You got it. Times 4 will work. Do the same to the bottom. And you get 32 peeps. And that's that. So you guys are going to do exercises. What was this, 2? Okay, so you'll do 3, 4, and 5. Okay? No matter what tonight, if you can't get the exercises done, at least do the exit ticket, because that's the only thing that's getting collected. So let's just say you do 3 now. Tonight you do, let's say you do 1 problem, 4. If you can't get 5 done, that's okay, but do the exit ticket. Okay? All right, pair up and go.